Consider this mass on a spring oscillating up and down without any type of resistance at all. When there's no resistance to slow it down, we call that oscillation without damping. Damping would be the friction or some medium that would slow it down, but this one has no damping. And look to the left, we have a spring coming out of the ceiling, and it has a block, a mass. And in the first position, y is equal to 5. In the second position, y is equal to 0. And in the third position, y is equal to -5. Now we call y the displacement from the rest position. The rest position is at y equals 0. So when it's up at y equals 5, it's in a compressed position. It's being pushed up. And when it's down at y equals -5, it's in a stretched position. So you see how it'll oscillate up and down. It will pass through the rest position over and over again as it goes up and down. Now, I want you to notice the corresponding graph for this motion of the spring, the oscillating spring, has the y-axis, the displacement from rest, and we've marked +5, 0, and -5. And then the horizontal axis is the time axis, t. And when the mass is fully compressed, it's at a level 5 on the y-axis. And when it's fully stretched, it's at a level -5 on the y-axis, and when it's at rest, it's at 0. So I've marked the different positions on the graph as time continues from left to right. Time starts at 0, and this thing starts oscillating back and forth, and you can see how it goes all the way up to the fully compressed position, then back down through 0 to the fully stretched position, then back up to 0. So it's oscillating back and forth, and as time passes, the graph moves. The wave and the graph moves from the left to the right. Okay, so here's our situation. We're given a mass that's suspended from a spring. The spring is at equilibrium when y is equal to 0, and that's when time is 0. So we're going to start this motion at equilibrium, t equals 0, y equals 0. In other words, the object starts at displacement 0. Another fact, 10 centimeters is the max distance the mass moves up or down. In other words, the amplitude is the absolute value of A. It's equal to 10. Another fact, the time for the mass to move from the max up displacement to the max down displacement and back, one complete cycle, is 4 seconds. That implies that the period t is equal to 4 seconds. Now, with all of this information, we're asked to find the equation of motion. SHM means simple harmonic motion. We call it harmonic when it oscillates back and forth. Simple harmonic motion. Find that equation of motion and the frequency and make the assumption that the A value is positive. We know the absolute value of A is 10, but we need to know what A is, and they're going to give us a hint. The A value is going to be positive for this problem. Okay, so let's break this down into steps, how to find the equation of motion. Step 1, since the displacement starts at 0. In other words, the y value is 0. That implies that we're going to use the sine equation for the equation of motion, not the cosine. Y equals A times sine times omega times t. Okay, step 2, find the A value. Well, we know the amplitude, the absolute value of A. We already determined that the absolute value of A, in other words, the amplitude, is equal to 10. And we were told to assume that the A value is positive. So that tells us that the A value in the equation is going to be positive 10. Step 3, okay, we're going to find omega. We're going to recognize that the period t is equal to 4. We saw that in the given information. But period is defined to be equal to 2 times pi over omega. So solve that equation for omega, and you'll get omega equals pi over 2. Omega equals pi over 2. Step 4, the frequency is always the reciprocal of the period, and we know that the period is 4, so it's going to be 1 over 4. But another way to calculate it would be it's also equal to omega over 2 pi. Omega is pi over 2, so it's pi over 2. Pi over 2 divided by 2 pi. So if you simplify pi over 2 divided by 2 pi, you get the same answer we got when we turned the period 4 upside down. It simplifies to 1 over 4. So there's 2 ways of doing it, And I showed you both ways to find the frequency. It's 1/4 cycles per second. And therefore, the simple harmonic motion equation of motion for this problem is going to be, plug the values in. Y equals A is 10 times the sine of omega, which was pi/2, times t. Now, we didn't plug in the frequency, but that was just something that we noted, that it moves 1/4 of a cycle every second. And that's our answer for the equation of motion.